Good morning, sixth graders. Today we are going to spend some time working on writing algebraic expressions. So on Monday you learned a little bit about writing numeric expressions. Numeric expressions are expressions that only contain numbers. Today we're going to be working on algebraic expressions, which are a little bit different because they contain something called a variable, which is not a number. We actually represent a variable with a letter. So let's start by writing out some definitions. So the first definition that we're going to write down is the definition for variable. And a variable is a symbol for a value that we don't know yet. Most of the time that symbol, well, all the time that symbol is used is a letter. A lot of the times it's either X or Y, but it can be any letter. But as you get older, most of the time you'll see that it's normally X and Y. So a variable is a symbol for a value that we don't know yet. And then to use that definition, we are going to write down another definition, which is the definition of an algebraic expression. So an algebraic expression is a math expression with at least one variable, but it can have more variables, but at least one variable and one operation. And that means addition, subtraction, multiplication, or division. Okay, so now that we've got those definitions, we are going to use those to help us work through some problems in our notes. So let's look at our first problem. And that says, Joe always reads 2 more hours than Frank. How can you write an algebraic expression to represent how much Joe reads? What I'm going to do for this problem is I'm going to make a table and just fill it in kind of with the information that I know based on the problem. So I'm going to have my left side of my table be for Frank and the right side of my table be for Joe. So I know that Joe always reads 2 more hours than Frank. So let's say that Frank reads 1 hour. I know that Joe reads 2 more hours than that, so it would be 1 plus 2. So Joe is going to read 3 hours. What if Frank decides to read for 2 hours? If Joe always reads 2 more hours than Frank, then it's going to be 2 hours plus the 2 extra hours that Joe reads to be 4. If Frank decides to read 3 hours, then it's going to be his 3 hours plus the 2 extra hours that Joe reads, so Joe will read 5 hours. Okay, so we should hopefully be starting to pick up on that pattern. What if, though, we don't know how much Frank reads? We just know Frank read some hours this week. We don't know how much, but we know that Frank read something this week. Since this is a value that we don't know yet, we can represent that Frank read some hours with a variable. So I'm going to do the variable X. We don't know how much Frank read, so I'm just going to say Frank read X hours. If we follow this pattern of always starting with what Frank read X hours, we know that whatever Frank reads, Joe reads 2 more hours than that. So if Frank read X hours, Joe's going to read 2 more hours than that. So however much Frank reads, we have that represented with the letter X. Joe is going to be an overachiever and read 2 more hours. Okay, so this would be our algebraic expression to represent how much Joe reads. Whatever Frank reads, X plus 2 more. Okay? Let's try another one. This one says, Miss Williams bought some Christmas presents. Each present cost $20. write an algebraic expression to show how much Miss Williams spent. Okay, so kind of on the same page, we can make a table to show how much money I spent on Christmas presents. Okay, so one side of my table is going to be my number of presents. And the other side of the table is going to be my cost. How much did I spend? Okay, so if I bought one Christmas present, that Christmas present is going to cost $20. Let's say that I go out and buy 2 Christmas presents. Each Christmas present costs $20, so I'm going to take 2 times 20 to know that I spent $40. If I bought 3 Christmas presents, 3 presents times 20 is $60. Okay? Now, my problem says Miss Williams bought some Christmas presents. You don't know how many Christmas presents I bought. So we can represent that word sum with a variable because that's our unknown value. Okay, so let's say that I'm going to represent the word sum with my variable of x. If I follow this pattern, I'm always taking the number of presents times my $20 that I know my presents cost. So I'm going to take my number of presents times $20, and my numeric expression is, I didn't need to put an equal sign there, I apologize. My numeric expression is x times 20. Now, something that I want to point out is that you might notice this gets a little confusing with this x and this x for a multiplication sign. So a lot of times what we'll do is we'll kind of combine those two. So you could either, instead of putting a multiplication sign, you could put a dot like that to show x times 20, but even that can get confusing because this x still kind of looks like a multiplication sign. So most of the time what we do when we have multiplication with a variable is we squish them into one term like this. You always put the number first. That's called our coefficient. You always put the number first, so 20x is the same thing as it's equal to 20 times x. But because this gets kind of confusing, we normally squish them together like that and do the number with the letter, with the variable right next to it. 20x is the same thing as, that should be a 20, is the same thing as 20 times x. Okay, let's do just a few more practice problems. I'm going to give some expressions and words, and we're going to try to write them as an algebraic expression. So we'll start with this first one, which is 5 more than f. So my variable is f, and my algebraic expression is 5 more than f. The word more tells me that we're going to add. So I'm going to start with f, and I need to have 5 more than f, so I'm going to add 5. You could also have 5 plus f. Remember, for addition, we can switch them back and forth. So either of these algebraic expressions represents that, that word form. Let's try another one. 18 times g. The word times tells me that we are going to multiply. Remember, when we are multiplying with variables, we kind of squish them together in one term. So I'm going to take 18 times g, and it just looks like that. A third example is q divided by 7. I'm going to put a little thing on that so it looks like a Q and not a 9. Remember that we can represent this a few ways. We could write Q divided by 7, or we could write it as a fraction since fractions are division, and we could have Q over 7 like that. And then the last one is one that I specifically want to talk about because this one can get very confusing. 10 less than e. It's very tempting when you see this to just write it out exactly how it says. So you most of the time know that less than means to subtract. So it's very tempting to do this, 10 minus e. However, we need to make sure that that is true. What if in this problem e was 14? If I asked you, what is 10 less than 14? You would tell me that 10 less than 14 is 4. So when you're finding 10 less than a number, or anything less than a number, you start with this term first. So we're going to start with e and then subtract 10. Because if e was 14, we would do 14 minus 10 to find 10 less than 14 is 4. So in this case, we have to do e minus 10 to find out what 10 less than e is. Today you are going to be doing some problems similar to these 4, where you have to write out the algebraic expression based on the number sentence that we gave you. And you'll have some word problems kind of like this one, where you have to write an algebraic expression based on that word problem. If you have any questions, please let your teacher know, and have a great Thursday.